Hello everyone, welcome to the lecture Inferencing using Pre-trained Model of TFOD 2.x. So here we'll be doing the setup verification, then inferencing with some pre-trained, the default model that in the collab tutorial it is available. Then we will try to pick a pre-trained model from the model zoo. Then we'll be testing with some sample images and then our own images that we will be using. So let's jump. Okay, so here our notebook was running. Okay, so I will just try to reconnect. Well, the first thing that I will try to execute here is this one, this cell where the imports are taking place. Okay, so everything is working fine, so no errors. So I think we can proceed. Okay, some patches have been added, so the code is compatible with the version, the TensorFlow version 1. And right now, this is the model loading technique. We just changed a lot. You can see actually saved model format. This came into the picture in TensorFlow 2. So right now, the model that we are downloading, okay, so it's something like this is a generic format that has been provided. So I will just try to run this particular function. Okay, so where is our label map? So I have to just pass that particular path and you can load it. Okay, and this actually in TensorFlow 1, okay, we used to use a for loop and then we used to iterate over like image1.jpg. So right now you don't need a naming convention. So it will simply pick up the JPGs files. So it's a good thing, some good code changes I will say. Then the default one that right now I am using is SSD MobileNet V1. So if I just try to go here, I will just copy this one and in the model zoo, just try to search this one. Okay, so I think I should remove that one. SSD MobileNet V1 Coco. This is the version that we will be using right now. So I think maybe because of the naming format, okay, because of that it won't work, but we'll be actually using the SSD MobileNet version 1. So right now I'm just passing the name of the model. So actually if you check the link, how it works. So right now if I just try to execute this particular model, it will try to download this but from this link. So you can see object detection / SSD mobile net. Okay. And if I just try to go here with the V1 version. Okay. So this is a different version. Okay, so you just need to check the link that is coming below. I know it's in very small actually. Okay, so in the left hand side at the bottom corner, you should always check the link for which of the model that you are using currently. So based on that, you have to give the exact model format. So let me, I think it's downloaded. Okay, it's the SSD MobileNet version 1 Coco 2017. The model is loaded. Okay, so what are the inputs actually? So always the input to a model will be an image tensor. So actually here it will be written, okay, an image tensor. Okay, so right now it's none, 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 none because no images are passed. Then we'll check the signatures. Okay, so what are the output data types? So output data types you can see all are float 32. Okay, and then finally the output shifts. So let's go into detail to this one. So right now it's talking about the output data types. For example, detection boxes. So what detection boxes will consist of? It will consist of the bounding boxes. Then detection classes. Okay, so this class will hold basically that particular class integer. For example, if you are mapping dog to 1, that 1 will be there. Okay, then cat to 2. Okay, in that way it based on the label map.pbtxt what indexing or basically what category indexing has been done for you. Then the next step, detection course. So this is basically the confidence score of the detection. And finally, num underscore detection. So it can be an integer also, but right now they are using it as a float 32 because it will be a number. It cannot be in fraction. Okay, and these are the shapes. So by default, okay, so the total number of detections will be 100. It's something like by default we are mentioning. Then the total number of classes is something like we are assuming it like 100 will be there. If 100 detections are going to take place, then 100 classes will be there for sure. Then detection scores, okay, so it's something like right now the shape will be like in 100. Okay, the total number of detections, none is actually, it can be in 1D because it will consist of only integers. And then right now we are doing the inferencing on a single image. Okay, where we are giving the input to an image, then we are converting it to a tensor, we are adding a new axis, then we are checking the model signature for serving. Okay, and then finally we are getting this four important values, which is number of detections, detection classes, okay, detection boxes, detection mask. Mask is used for segmentation. Right now we won't be using that. And finally we will return this as a dictionary. Now show inference. So here what actually, so when we are asking about show inference, mean to show the images, basically the predicted images that we want. Okay, so here you can see actually it's taking two arguments. One is the model, which model you are passing and which image you are passing. Then it will convert that into an array. Then it will run that particular image and the model through this above function that we have defined. Okay, and then it will try to draw the bounding boxes. So using this particular visualize boxes and levels on an image array. And then these are the things that will be returned. And finally the images will be displayed. So let me just try to run this one. And now you will get your results soon. So right now we are using the Coco one. So I will try to change the model and I will see actually how it works. Okay, so dog 94%, dog 93%, you can see actually for one it's done, for the second one also it's done. So it's pretty similar, okay, but it's something that is better because the complete framework has been revised. So for image, okay, so right now what I will do, the next step, I will try to change some images. So for that I have to change this particular path. So right now this is the path that we are taking. So what I will do, I will just copy this path just to take a reference. Okay, it's something like hash. I will put it as a comment because this is the actual format how it has to be. Okay, and then let me go to model 2 and try to pick something from here. So let me use this model. Okay, so this is the model link to download. Okay, so actually I will be checking this link that it's exactly same, and then based on that I will do the changes. So here actually you can see, so this till this point it's fine, but after this there is some change. So this particular thing needs to be added there. So I will try to add in the model loading function. So here is the model loading function. Okay, slash. Okay, now I think the new model will be loaded. Okay, and I just need to pick this particular end part till the date, because at the end dot tar it will be added. So the changes are done. Let's hope it works. Okay, downloading data. Okay, so there is an HTTP error that we got. Okay, we have to check actually why we got that particular error. So TensorFlow models object detection slash. Okay, so this link and this link should be exactly same that we are trying to download. Okay, there is a before and there is slash tf2. We forgot that, so we'll just try to add that one. tf2. Oh, now let me try to run. Okay, now the downloading has started. It means that we are downloading the exactly correct model. Okay, these are some warnings. It's fine. Now this model is a little bit huge as compared to last time, so the loading time may be a little bit high. Lot of earnings, I will say, from this particular library of ABSL. Okay, now the model loading has been completed. To detection model, these are pretty same actually. Okay, some new things got added actually. You can see detection anchor, indices, then detection boxes, classes, multi-class scores. Okay, number of detections, but actually the things that you need, it's available, so you don't need to worry about that. Okay, so based on the signatures observing default, okay, then again this has changed because this particular thing has changed. Okay, now we'll be using the same inferencing, show inference. Okay, in the next step, what I will do, I will just try to use some new images. So let me just now splash. Okay, so it's taking some time, fine. So let me just check this people section. Okay, so let me just take a random picture. Okay, another picture I will take something related to furniture. Furniture. Okay, so I think it will work. Yeah, so these two photos I'm taking into account. So I will just save them as for in the desktop. Okay, so I've saved them. Now I'll be using them here. So right now you can see actually both of the inferences have been done. Okay, so something this new green game, last time you actually saw this person was not being detected. Okay, but right now even this person is being detected. So it can understand that it's a leg of a person. So it's a very good thing actually from the efficient dead family. So now I will just try to upload something to research because right now everything we are picking from the test images folder. Where is our test images? It should be inside the object detection folder. Inside object detection test images right here. I will just I will try to upload the new photos. Okay, and even the old ones. Okay, so I think they got uploaded. So what I will do right now, I will just try to reload that test images part where I was loading. Okay, so right now if I do, okay, so it should reflect actually. So inside test images, okay, snapshot, okay, these are the folders that got created, okay. So let me just rename them. Okay, the format is like JPG. Okay, so what I will try to do because of this, it could not identify JPE. Okay, so I have added one E here because of that alpha channel, and you can see actually this four photos came. Okay, So let me just try to run this particular function. Then again this one. And finally we'll be looping them over the test images. So I will close this one and we will get our results. Okay, so you can see actually the results right now. Something that has been detected as chair. Okay, so a lot of chairs. This one as couch. Okay, so I will say the results are good. Okay, so two persons are here right now. So this result is also fine. Then this one actually a dining table. Okay, so it's a very good thing that it's identifying that potted plant, cup. Okay, cup, fork. Okay, then person. Okay, so it's trying to get all the details. Okay, now person, then an umbrella. So it's a mistake actually. So it's something like they are trying to cover themselves. So based on that idea, it's trying to think it's an umbrella, but it's actually a pretty good work. Okay, so in this lecture, we have done the testing with some other pre-trained model, and even we have added our test images. And finally, I will say it's working very, very good. So guys, see you in the next lecture.